Multimodal models and the evolution of virtual beings, a new frontier in human-AI interaction. The fields of artificial intelligence and human-computer interaction are witnessing a convergence of two groundbreaking technologies, multimodal models and virtual beings. Multimodal models are AI systems capable of processing and integrating multiple types of data, such as text, images, and audio. Virtual beings, on the other hand, are AI-powered digital entities designed to interact with humans in increasingly sophisticated ways. The integration of these technologies promises to revolutionize the way we interact with AI across various domains. Multimodal models, exemplified by innovations like OpenFlamingo, have significantly advanced the capabilities of AI systems to understand and process diverse forms of information. Simultaneously, virtual beings have evolved from simple chatbots to complex digital avatars used in entertainment, customer service, and education. The synthesis of these technologies is poised to create a new paradigm in human-AI interaction, offering more natural, context-aware, and empathetic digital experiences. This paper explores the potential of combining multimodal models with virtual beings, examining the technical foundations, current applications, and future prospects of this integration. We will delve into the transformative impact this convergence may have across various industries, while also addressing the ethical considerations and challenges that arise. By the end, we aim to present a comprehensive vision of how multimodal virtual beings could enhance human capabilities and experiences in the digital age. Multimodal models represent a significant advancement in artificial intelligence, moving beyond the limitations of single-mode data processing. These models are designed to simultaneously interpret and integrate information from various sources, such as text, images, audio, and even video. This capability allows for a more holistic understanding of complex scenarios, mirroring the way humans process information from multiple senses. At their core, multimodal models employ sophisticated neural network architectures that can handle different data types. For instance, they might use convolutional neural networks, CNNs, for image processing, recurrent neural networks, RNNs or transformers for text analysis, and specialized audio processing layers. The key innovation lies in the model's ability to create joint representations of these diverse inputs, allowing for cross-modal understanding and inference. One prominent example of a multimodal model is OpenFlamingo, which combines vision and language models to perform tasks that require both visual and textual understanding. Such models can describe images, answer questions about visual content, and even generate images based on textual descriptions. The advantages of multimodal systems over their unimodal counterparts are significant. They can provide more accurate and contextually relevant responses by considering multiple types of input. For instance, in a customer service scenario, a multimodal system could analyze both the customer's text query and their facial expression, via video, to provide a more appropriate and empathetic response. However, multimodal models are not without challenges. They require vast amounts of diverse, high-quality data for training, which can be difficult and expensive to obtain. Additionally, the computational resources needed to train and run these models can be substantial. There are also ongoing challenges in achieving true semantic understanding across modalities and in handling scenarios where different input types provide conflicting information. Virtual beings have come a long way since the early days of simple chatbots. Today, they encompass a wide range of AI-powered digital entities, from photorealistic avatars to more stylized characters, all designed to interact with humans in increasingly natural and sophisticated ways. The evolution of virtual beings has been driven by advancements in several key areas: natural language processing, computer graphics, and machine learning. Modern virtual beings can engage in complex dialogues, display emotional responses, and even adapt their behavior based on the user's interactions. Currently, virtual beings find applications across various domains. In the entertainment industry, they serve as digital influencers, video game characters, and virtual companions. Customer service has seen widespread adoption of AI-powered assistants, capable of handling inquiries and providing support around the clock. In education, virtual tutors and learning companions are being used to provide personalized instruction and support to students. Despite these advancements, traditional virtual beings still face limitations. Many struggle with understanding context, maintaining coherent long-term interactions, and adapting to unexpected scenarios. They often lack the ability to process and respond to non-verbal cues, limiting the naturalness of their interactions. Additionally, most current virtual beings operate within a single modality, typically text or speech, which constrains their ability to fully engage with users in more complex, real-world scenarios. The integration of multimodal models with virtual beings represents a significant leap forward in creating more intelligent, adaptable, and engaging AI entities. This convergence enhances the capabilities of virtual beings in several key areas. Enhanced interactivity and communication is perhaps the most immediate benefit. By leveraging multimodal models, virtual beings can now process and respond to a wider range of inputs. For instance, a virtual assistant could analyze both verbal commands and visual cues from the user, leading to more accurate and context-aware responses. In a retail scenario, a virtual shopping assistant could provide personalized recommendations based not only on the customer's verbal requests but also on images of their current wardrobe or living space. Improved emotional intelligence and empathy is another crucial advancement. Multimodal virtual beings can recognize and respond to non-verbal cues, such as facial expressions, tone of voice, and body language. This allows for more nuanced and empathetic interactions. For example, a virtual therapist could adjust its communication style based on the patient's emotional state, as inferred from both verbal and non-verbal inputs. Dynamic content creation and storytelling capabilities are significantly enhanced by this integration. Virtual beings can now generate more engaging and contextually relevant content by drawing from multiple input types. In an educational setting, a virtual tutor could create personalized learning materials that combine text, images, and even interactive elements, adapting to the student's learning style and progress. The potential applications of multimodal virtual beings span numerous industries, each benefiting from more sophisticated and context-aware AI interactions. In retail and e-commerce, virtual shopping assistants can provide highly personalized experiences. They can analyze images of a customer's existing wardrobe, understand their style preferences through natural language conversation, and even process videos of the customer to suggest items that complement their body type and coloring. Education and training stand to benefit greatly from this technology. Adaptive learning systems powered by multimodal virtual beings can create immersive, personalized learning experiences. Historical figures could be brought to life in VR environments, engaging students in interactive dialogues while responding to their actions and expressions. In professional training, virtual instructors could provide real-time feedback on both verbal responses and physical actions, enhancing the effectiveness of simulations for fields like medicine or emergency response. The healthcare industry could see transformative applications, particularly in mental health support and medical training. Virtual therapists could offer more empathetic and personalized support by analyzing a patient's tone, facial expressions, and verbal responses. In medical training, virtual patients could present complex symptoms across multiple modalities, challenging students to make accurate diagnoses based on a holistic assessment. Entertainment and gaming industries are poised for significant advancement. Next-generation NPCs, non-player characters, in video games could offer unprecedented levels of interactivity, with behaviors and dialogues that adapt dynamically to the player's actions, expressions, and verbal inputs. This could lead to more immersive and emotionally engaging gaming experiences. Accessibility and inclusion efforts can be greatly enhanced by multimodal virtual beings. Advanced assistive technologies could provide real-time sign language interpretation, audio descriptions of visual content for the visually impaired, or simplified language versions of complex texts for those with cognitive disabilities. These technologies could significantly reduce communication barriers and increase digital accessibility for diverse user groups. As with any advanced technology, the integration of multimodal models and virtual beings raises important ethical considerations and challenges that must be addressed. Privacy concerns are paramount when dealing with multimodal data processing. These systems often require access to sensitive information such as visual and audio data from users' environments. Ensuring the security of this data and maintaining user privacy is crucial. Clear guidelines and robust security measures must be implemented to protect users' personal information. The uncanny valley effect and user acceptance present another challenge. As virtual beings become more realistic and human-like, there's a risk of users experiencing discomfort or rejection. Striking the right balance between realism and stylization will be crucial for widespread acceptance of these technologies. The potential for misinformation and deepfakes is a significant concern. Multimodal virtual beings capable of generating realistic images, videos, and audio could be misused to create convincing fake content. Developing robust authentication methods and promoting digital literacy will be essential to mitigate these risks. Ensuring diverse representation in virtual beings is crucial to avoid perpetuating biases and stereotypes. Developers must strive to create virtual beings that reflect the diversity of human populations in terms of appearance, language, and cultural backgrounds. Looking ahead, the integration of multimodal models with virtual beings opens up exciting possibilities for future development. The combination of these technologies with other emerging fields, such as brain-computer interfaces and haptic feedback systems, could lead to even more immersive and intuitive human-AI interactions. Imagine virtual beings that can respond to users' thoughts or provide physical sensations as part of their interactions. There's also potential for the development of more general-purpose AI assistants. These advanced virtual beings could seamlessly switch between different roles and tasks, from personal assistant to educator to creative collaborator, all while maintaining a consistent personality and understanding of the user's preferences and needs. In the context of the emerging metaverse, multimodal virtual beings could play a crucial role. They could serve as guides, moderators, or companions in virtual worlds, enhancing the social and interactive aspects of these digital environments. The convergence of multimodal models and virtual beings represents a significant step forward in the field of artificial intelligence and human-computer interaction. This integration promises to create more natural, context-aware, and empathetic AI entities capable of enhancing human capabilities across various domains. From revolutionizing education and healthcare to transforming entertainment and customer service, the potential applications of this technology are vast. However, realizing this potential will require addressing significant technical challenges and important ethical considerations. As we move forward, interdisciplinary collaboration will be crucial. Computer scientists, ethicists, designers, and domain experts must work together to shape the development of these technologies in ways that are beneficial, ethical, and inclusive. The future of human-AI interaction lies not in replacing human capabilities, but in augmenting them. By creating virtual beings that can understand and respond to the full spectrum of human communication, we open the door to a world where AI can truly enhance our daily lives, support our goals, and expand our potential. As this field continues to evolve, it will undoubtedly play a pivotal role in shaping the future of our increasingly digital world.